be same. Everything in the sense, the length, side, the angle measurement, and everything should be same. So whenever I say these two triangles, that is triangle ABC is congruent with the triangle PQR, it means that the AB is equals to Q, BC equals QR, and the AC is equals P. Then only we can say the triangles are congruent. Not just that, we even can say area of the triangle ABC is equal with the area of the triangle PQR. That's what the area, that's what the congruency means. Two figures are congruent mean their length, the measurement of their angles, and the area, everything should be equal. But what do you mean by the similar figure? As the name suggests, similarity, two things will be similar. For example, there is a triangle ABC and there is one more triangle PQ. P, this is Q, this is R. So ABC and PQR, these two figures will be similar only when the angles are equal, or so these two figures are similar figures, we can say only when if the first figure and the second figure holds the following properties. The properties are that the measurement of the angles need to be exactly equal with the other one. So you can say A is equals to P, B is equals to Q, and C is equals to R. Then we can say these two triangles will be similar. This is the symbol for similarity. We can say the triangle ABC is similar with the triangle PQR. And one other way to be a similarity between two triangles will be their corresponding side should be in a proportion. So their corresponding sides in the sense, for example, AB by BQ should be equals to BC by QR should be equals to AC by PR. The corresponding sides should be in a proportion or the corresponding angles need to be equal. That is the basic rule to be two triangles similar. So let us try to understand and uh, note them down properly. To have a similarity between two triangles, the first thing we should have the either we should have the angles equal. So this is a triangle ABC and a triangle PQR. So the first thing that it should have either the corresponding angles are equal, either it should have corresponding angles should be equal, or it should have their corresponding sides are proportional. Corresponding sides should be proportional. Then only you can say either any one of these two rules, if they follow, it means the triangles are similar. So the triangle ABC will be similar with the triangle PQR. Now, What is the difference between the congruency and the similarity? In congruency, we had both the triangles should be exactly same, even their area should be same. But in similarity, that's quite different. They don't need to be same, but they should look like same, and their area should not need not to be equal to same. So from here we can say that all the similar triangles are not congruent triangles, but all the congruent triangles are similar triangles. That's the relation between the congruency and the similarity. Now, the first thing we have in the similarity is called the Thales theorem or basic proportionality theorem and or BPT theorem. So we are going to start with the Thales theorem. So what is called Thales theorem, or it is also known as BPT theorem. BPT stands for basic proportionality theorem. So in this case, the statement says that we should have this is the basic proportionality theorem statement. So in this case, it's given that if a line drawn parallel to one side of the triangle to intersect the other side of the triangle in distinct points, then the other two sides are divided in a same ratio. We can see this is a very famous question even in case of CBSE. It appears 6 times at least. So we will draw a triangle first. So say there is a triangle, the triangle ABC. So in this triangle, it is given that a line drawn parallel to one of the sides of the triangle intersect other two sides in distinct points. So I need to draw a line parallel to the other side of the triangle which will intersect the triangle sides in two distinct points. So DE, D and E, and D is the line which is parallel to BC which is given in the question. We have to prove that AD by DB equals to AE by EC. AD by DB equals AE by EC. Now, how we can prove it? We have to prove AD by DB equals AE by EC. And that's what the Thales theorem is. So, we will join the BE and CD. So, the first construction that I should do is to join the BE and the CD. These 2 points I should join first. Now, next what we should do, we should draw two perpendicular EL and DM upon AB and AC. That's the next thing I should do. That is, I should draw two perpendiculars, that is DM and EL on AB and BC. So these are the two perpendiculars drawn, EL and DM. This much is the construction. So in the construction portion, what we did, we have drawn, we joined we joined BE and CD, and we have drawn DM perpendicular to AC and EL perpendicular to AB. So these are the two construction we did. Now the proof. So how we can prove it? So we have to first take the first two triangle. That is, I'm going to find out the area of the triangle ADE, the area of the triangle ADE. So what will be the area of the triangle ADE? It will be half into AD into EL, using the formula half into base into height. Using this formula, we got the area of the triangle ADE as half into AD into EL. Now, the area of the triangle DBE, the area of the triangle DBE, which will be half into DB into EL. That is for the area of the triangle DBE. For this DBE, we got the area as half into DB into EL. Sometimes we can encounter the situation if the triangle is drawn something like this. Its perpendicular or the height can be outside the triangle also. Okay, but still that is the perpendicular or that is the height of the triangle. So in that way, we got the triangle DBE area as DB into EL into half. Let's try to get the ratio between the area of the ADE and DBE. So we will do area of the triangle ADE upon area of the triangle DBE. So it gives you half into AD into EL by half into DB into EL. So obviously what we can do simply, we can cancel out few terms. I can cancel out half and half. I can cancel out EL. It gives you AD upon DB as the area of the ratio between the area of triangle ADE and DBE. Now, let's take it as an equation 1. Now, we're going to form one more equation, something like this. So in that case, we are taking the area of the triangle ADE and ECD. Area of the triangle ADE by area of the triangle ECD. We are taking this triangle ECD. ECD. That still gives me half into, for the area of the ADE. Earlier we have taken the height as EL, but also I can take the height as DM. So in that case, it will be AE into DM by half into EC into DM. Because for the ECD also, this DM is the perpendicular to the opposite side, or that is the height for the triangle. So we can simply cancel out half and half, and we can simply cancel out that DM and the DM. That also we can do. We can cancel them out. So it gives you the ratio as AE by EC. AE by EC. Now look, what I need to prove, I need to prove that AD by DB should be equals to AE by EC, and we already got the ratios. Let's take it as the equation number 2. So next what I need to do, I need to prove that the first and the second thing is equal. This left hand side of the first equation and the left hand side of the second equation should be equal. Then only I can say that AD by DB is equals to AE by EC. So we have the numerators same. Now I just need to show that their denominators are same. Obviously the area of the triangle BDE, area of the triangle BDE is equals to the area of the triangle DEC, because they are under same base, they are having same base and they are under the same parallel line. So the reason will be same base, same parallel line. That's why their areas are same. So that means we can say the second equation can be changed into triangle ADE divided by area of the triangle DBE, and that's also equals to AE by EC. So if I compare this equation, the first one, with this modified second equation, I can simply write AD by DB is equals to AE by EC. That's what the Thales theorem says. So it's proved. Now, so the Thales theorem, that was the Thales theorem or basic proportionality theorem, BPT theorem, which says if I have a triangle and if I draw one line which is parallel to one of the side of the triangle, intersect the other two side of the triangle in two distinct points, it will divide the triangle, or if it will divide the other two sides in a same ratio. Now let's try to use this Thales theorem in more useful ways. So let's try this. Let's say we have a triangle ADE, ABC, ABC, and we have a side which is parallel to the one of the sides, that is DE. These two are parallel. So by BPT theorem, or by Thales theorem, what we can write? We can write that AD by DB equals AE by EC. Now, what we should do now? Let's add one both side. AD by DB plus 1 is equals to AE by EC plus 1. So let's add one both side. After adding one both side, what we can do? We can take the LCM. AD plus DB by DB is equals to AE plus EC by EC. So AD plus DB gives you AB by DB is equals to AC by EC. Even you can prove in the same way that in place of DB you can write the other two sides like AD and AE. That also will work. That is AD by AB is equals to AE by AC. This also can be done. So let's summarize this. Let's see how many things we can write actually from this BPT theorem or the Thales theorem. The first thing that we can write is AD by DB equals AE by EC. AE by EC. The second thing that we can write is AB by DB equals AC by EC. third thing we can write is AD by AB equals AE by AC. So these are the things we can write from Thales theorem. So let's try to solve a question. Let's see how this question can be solved. For example, I'm taking a question from the CBSE paper, previous year paper, that is from 2006. So this question says we have to prove, it's given that DE is parallel with BC. The length of AD is given 2.5 centimeter. The DB is given 3 centimeter. AE is given 3.5 centimeter. We need to figure out the length of AC. So I know the AD, I know the DB, I know the AE, I need to figure out AC. So I can simply get the EC. If I can get EC, I can add that with AE to get the entire length of AC. Because from the AC, I already know part of AC, that is AE. It is known to me 3.75 centimeter. I just need to get the EC to get the entire length of AC. So let's see how I can use the Thales theorem to solve it. So first of all, in the Thales theorem, using the Thales theorem, I can write that in triangle ABC, DE is parallel with BC. This is very much important to write this statement because based on this parallel thing, we can actually write the Thales theorem or the BPT theorem. So you should write the statement before writing down the Thales theorem. You should not write down the Thales theorem directly. So AD by DB, AD by DB equals to AE by EC, AE by EC. Now, in the Thales theorem, that's by Thales theorem. So we should write by either by Thales theorem or you can write it by BPT theorem. So this is by Thales theorem. Let's write down the value of AD 2.5 by DB, that is 3, equals AE, that is 3.75 divided by EC. We don't know EC, so we'll keep it as EC. Now what? We need to simplify it. So we'll try to get the value of EC, which will be 3.75 times 3 divided by 2.5. I use the simple transposition method to solve it. So it is 3.75 times 3 divided by 2.50. You remove the decimal. Now you cancel this 2 by 25. It gives you 10. It gives you 15. Now you cancel the 15 by 5. That gives you 3. And this by 5. That gives you 2. So it gives you 9 by 2. So we're getting 9 by 2 as the EC of 4.5. So EC will become 4.5 centimeter. EC will become 4.5 centimeter. Now, let's solve one more question. But before moving to the next question, we should write the answer. So the answer will be hence the length of AC, which is nothing but AE plus EC, that is equals to AE length is given 3.75 and EC is given 4.5 centimeter. So that will be equals to 8.25 centimeter as the answer. So that is the final answer. We are getting the length of AC as 8.75 centimeter. In here, while you were writing that answer, you should not forget this units. These are very important that you should write down the units of the question. Now, let's do one more question, which is again based on the Thales theorem. And this is also a CBSE question. The question says, this is the statement of the question, and this is the image of the question. So it says that in the figure, in the given figure, DE is parallel with BC, AD by DB ratio is given 3.5 and AC is given 4.8 centimeter. We need to find out the length of AE. So we need to find out the length of AE. AC is given, the entire length of AC is given, and the AD and DB is given. Okay, so what we can do here, if I use directly the Thales theorem, then we can solve it. First of all, we will write that for triangle ABC, DE is parallel with BC. DE is parallel with BC. That's the first theorem we can write. Second thing we can write, is I can take the AE as x centimeter, because here the entire AC is given, so I am taking AE as x centimeter. So let AE is equals to x centimeter. So what will be EC then? What will be EC? The EC will be 4.8 centimeter minus x centimeter, or 4.8 minus x centimeter as the EC, length of EC. Now, using the Thales theorem, we can write AD by DB is equals to AE by EC. AD by DB equals to AE by EC. So what is AD given? AD by DB. This ratio is given 3 by 5. So I will write 3 by 5 equals to AE is X and EC is 4.8 minus X. Now, I have to solve it. Let's cross multiply it. So 5x equals to 3 into 4.8 minus x. So 5x equals to 4.8 times 3. That gives you 14.4 minus 3x. Move the 3x to this side. It gives you 8x, that is 5x plus 3x, 8x equals to 14.4. So x you are getting as 14.4 divided by 8. 14.4 divided by 8. That gives you 1.8 as the answer. So we are getting the value of AE as 1.8 centimeter, but we should complete our answer by writing the final statement. Hence, AE equals to 1.8 centimeter. That's the final answer we should write. So these are the types of question we have in the Thales theorem. But these are the one type of question where we only have the values. The values of other sides are given and we need to just put the values and get the answer. But sometimes they give you some questions which involves the proof. So let's do a question where we have to prove something. For example, the question is given this one. This is the question given. It also appeared in 5 and 7. And the figure is given this one. And we need to prove that in the given figure, DE is parallel with DE is parallel with AC and DF is parallel with AE. We have to prove that BF by FE is equals to BE by EC. Okay, let's see how we can prove it. This is a very simple question. I have to choose the triangle such a way we can use this length BF, FE, BE, EC. So for the triangle, first let's take the triangle BAE, this triangle, BAE, because in this triangle I have a set of parallel lines. Okay. So in between this triangle, I'm first choosing, let's write that for the triangle ABE, for the triangle ABE, what we know? We know parallel with DF is parallel with AE. That is what we can say. DF is parallel with AE. So if the DF is parallel with AE, what we can say using the Thales theorem, we can say the BD and DA ratio, BD DA ratio should be equals to BF and FE ratio. So we can write BD by BA equals BF by FE. That's the first thing I can say using the Thales theorem. Always, whenever you're writing this, you should write that it is by Thales theorem. Now, secondly, for the other triangle, let's choose one other triangle that, let's say the triangle ABC or BAC. For BAC, why I choosing it? Because I have one more parallel property there, that is DE is parallel with AE. So that's why I'm choosing that triangle. So for that triangle, I can write for the triangle BAC, DE is parallel with AC. DE is parallel with AC. So obviously by Thales theorem I can write BD by DA. BD BD by DA equals to BE by EC equals to BE by EC. So that's the second thing, second relation we are getting, and that's also by Thales theorem, or you can even write it as by BPT theorem. BPT stands for Basic Proportionality Theorem. Now, the first equation and the second equation, the left hand side is exactly same, right? Both the cases, the left hand side is exactly same. So we can do what? We can do from 1 and 2, we can write BF equals to BA by FE equals to this right hand side is equals to this right hand side. Second equation, right hand side. BA by FC equals to BE by EC. BA by FC equals to BE by EC. That is the second thing that we can say from this thing. Okay. So we can write that is from 1 and 2. That is from 1 and 2. So that is what I need to prove. So we can write final statement proof. So let's do one more question exactly similar, where it is also based on the CBSE previous year question. For example, this question. Okay. So this question says that just a second. Yeah. So that question says in a given figure, PA, QB, and RC each are perpendicular to AC. Okay. PA, QB, RC, all of them are perpendicular to AC line. All these are perpendicular to each other, such that PA length is X, RC length is Y, and QB length is Z. And BC length is given B and AB length is given A. Okay. We need to prove 1 by X plus 1 by Y equals 1 by Z. Okay. So we have to choose the triangle such a way we can use all this known data. So let's choose a triangle. Let's first of all, let's see why they have given this statement that PA, QB, RC each are perpendicular to AC. Each are perpendicular to, what does that mean? If a line, if two lines are perpendicular to a same line, it means they will be parallel to each other. It means they will be parallel to each other. That's what they mean. Here we have three lines who are perpendicular to a same line. So all these three are parallel. So that's what we can say from the first statement given in the question. So we can say PA is parallel with QB is parallel with RC. Now, let's choose a triangle triangle PQC for the triangle PAC. For the triangle PAC, we have QB is parallel with PA. QB is parallel with PA. So we can write that the triangle QBC is similar with the triangle PAC. QBC is similar with the triangle PAC. Because if you look at the triangle PAC, you can see this QBC and the PAC will be similar to each other because they holds this angle equal, this two angles are equal, so that means the triangles will be similar to each other. Now, if they are similar, we can say that QB by PA is equals to BC by AC. QB by PA equals to BC by AC. That means, what is the length of QB? Z by PA, X is equals to B by A plus B. That's the first thing we can say. Let's choose one more triangle that will be obviously RAC. Triangle RAC, in which again the QB is perpendicular parallel to RC. So we can write the triangle QBC is similar with the triangle RAC. QBC is similar with the triangle RAC. Once these two triangles are similar, we can write that QB by RC is equals to AB by AC, as these two triangles are similar, and two similar triangles should have their lines proportional. So from here we can write Z by Y, because RC is given Y. So Z by Y equals to A by A plus B. Okay, that's my second equation. Now I have to solve this two. What I can do, I can simply add the equation 1 and equation 2. So let's add equation 1 with equation 2. So if I add equation 1 into equation 2, I'm getting Z by X plus Z by Y equals B by A plus B plus A by A plus B. So Z by X plus Z by Y equals to A plus B by A plus B. So this side we are getting it as 1. Further I can do what? I can take Z common. 1 by X plus 1 by Y equals to 1. Now if I move the Z to the other side, it will become 1 by X plus 1 by Y equals 1 by Z. 1 by X plus 1 by Y equals 1 by Z. True. So this is what I need to prove. 1 by X equals plus 1 by Y equals 1 by Z. That is what we have in the Thales theorem and the basic proportionality theorem. There are a lot of questions which can came from this two portion, and it is very important portion in CBSE 10th. Now, using this Thales theorem, we have the midpoint theorem. Using the Thales theorem, we have the midpoint theorem. So what is midpoint theorem and how we can solve it? So the midpoint theorem says that if we have a triangle and in that triangle, if I have one side passing through the midpoint of the other two side, it that new side will be parallel and half of the third side. The new side will be parallel and half of the third side. So what it says? It says that if I have a triangle, for say we have ABC triangle, And we know the midpoints of the triangle ABC. This is the midpoint. This is D. And this is E, the midpoint. These two are equal. This is equal to this one. If I join DE, this DE will be parallel to BC and DE will be half of BC. DE will be parallel to BC, DE will be half of BC. So let's try to prove it. So we can write that is given a triangle ABC, a triangle ABC in which D and E, D and E are the midpoints, are the midpoints. These are given. Midpoints of what side? Of AB and AB and AC. We need to prove that DE is parallel with BC and DE is half of BC. That's what I need to prove. Now, how to prove it? Since we know that D and E are the midpoints of AB, we can write that AD is equals to DB and AE is equals to EC. As we know that D is the midpoint of AB and E is the midpoint of AC, we can write that AD and DB will be equal and AE and EC will be equal. So obviously we can even write AD by DB, which will be equals to 1, and AE by EC, which also will be equals to 1. So we can write AD by DB is equals to AE by EC. So that is from the first two equation we can say. Okay. Now, if AD by DB is equals to AD by DB is equals to AE by EC. So what we can say by Thales theorem, that obviously that DE is going to be parallel with BC. That's what the converse of the Thales theorem is. That if the lines are divided in a ratio, then obviously D need to be parallel with BC. So that's by converse of Thales theorem. That by converse of the Thales theorem, DE is parallel with BC. Now we need to prove, say, DE is half of the BC. Okay, DE is half of the BC. That is also we can prove. DE is half of BC. How we can prove? We can write from the Thales theorem that AD by AB is equals to DE by BC. That's by Thales theorem, or even you can use the similarity. Two similar triangles will be proportional to each other. This triangle will be equal and this is a common angle. So this triangle, obviously the triangle ADE will be similar with the triangle ABC. So from that statement we can write AD by AB equals to DE by BC. So what will be AD by AB? AD by AB will be twice of AD. Obviously, as we know, we can see that AD is equals to DB. So obviously AD will be half of AB, or AB will be twice of AD. That is equals to DE by BC. DE by BC. AD get cancelled. we are getting DE by BC is equals to half. So DE is equals to half of BC. That's the other part of the midpoint theorem. That's the line joining the midpoints will be the parallel to the third side and half of the third side. So that's what the midpoint theorem is. That's what the midpoint theorem is. So today we did the basic proportionality theorem. We did the similar triangles. We did the basic proportionality theorem, BPT theorem, which says that if you a line parallel to one of the side of the triangle will intersect the other two side in a ratio, in a equal ratio. So we can say AD by DB equals to AE by EC. We did few questions based on the Thales theorem, and then using the Thales theorem, today we also proved the midpoint theorem, which is one more very important thing in CBSE syllabus. We have a lot of questions based on this. Next will be angle bisector theorem. We will meet in the next session.